Pre-statistics. Function problems, part 2. Is this relation a function? The answer is yes. It passes the vertical line test. For every x, there's one and only one y. What is f of negative 1? When x is a negative 1, we have y being equal to 0. Number 2, what is f of 1/2? F of 1/2, what's the value of y when x is 1/2? So here's 1, there's 0, half is in between. We see that y value is a positive 1. Number 3, what is f of 5? When x is 5, what's the value of y? Well, we see that the largest x is 2. So this is what we call undefined. There's not a value. Number 4, what is the value of x where f of x is 0? So now we're looking for x values and we're given a y value of 0. So if we go to the y-axis, here's where y is 0. And we actually see here's a value of x, another value of x, a third value, a fourth, and a fifth. So there's actually 5 values of x when f of x is 0. When x equals negative 2, when x equals negative 1, 0, positive 1, and also a positive 2. Number 5, what is the domain? There's an endpoint of negative 2, so that's the smallest x, and it goes all the way to a positive 2. So there's an ending point for x, so all x values in between negative 2 to a positive 2. Because these are closed circles, they can equal. So we put our smallest x here, our largest, and x can be any value in between, and it can equal negative 2 and it can equal a positive 2. So that is the domain. Number 6, what is the range? Now we go to the y-axis. We see we have a minimum value here, negative 1, and we have a maximum value of a positive 1. So all y values in between negative 1 and 1 have a spot on this graph. Again, we write the smallest, negative 1, the largest is 1, so f of x can be any value in between negative 1 and 1, and they can equal those values, so we include equal to signs. Now if we were to write this in set notation, this would be bracket negative 1 comma 1 bracket. Number 7, what is the maximum value? So when we're asked this question, we're saying what is the largest y value for this function, and we see it occurs here and here. So when the maximum value is when y is 1, or when f of x is 1. Number 8, what is the minimum? What is the smallest y value? We see that occurs here and here at negative 1. So the minimum is negative 1. Number 9, where is f of x increasing? That means where on this graph is the slope positive. So if we begin at our endpoint here, from here to this point, this has a positive slope. So f of x is increasing. This is decreasing from this point up to the peak. This is an increasing slope. From this point to the end point, this is increasing. So we have three sections where f of x is increasing. So for the first section, this is -2, this is -1, so this is -1.5. So from -2 to a -1.5, values of x will make the function increase. Now we don't put equal signs on here because we can't increase at a point. Okay, the second area is from a -1/2 to a +1/2. And the last section is from 1.5 to 2. There are three pieces of this function where it is increasing. Number 10, where is f of x decreasing? Well, from this maximum to this minimum, that's decreasing. That's increasing when we have this maximum to this minimum. That is also decreasing. So we have two regions where f of x is decreasing. So this would be a -1.5 to -0.5, and from 1/2 to a +1.5. And now if we were to write this in set notation, this would be parenthesis -1.5, -0.5, close parenthesis, and 1/2, comma, 1.5, close parenthesis. Number 11, where is the rate of change equal to 0? That means where on this function is the slope equal to 0, and that's a horizontal part. There isn't one, so the answer to number 11 is there isn't a place on the graph where the rate of change is 0. Number 12, where is f of x positive? That is in quadrants 1 and 2. So anything above the x-axis, y will be positive. So that's this part, this hump of the graph, and also this hump. So again, we have two sections. So this is from -2 to -1. And we have from 0 to a +1. Set notation, parentheses, -2, comma, -1, and from 0 to 1. 13, where is f of x negative? That's in quadrants 3 and 4. All these y values here are negative. So it's this hump and this one. So there's 2. So from -1 to 0, and from +1 to 2. And again, we would not use equal signs here because at these points y is 0, and 0 is neither positive nor negative. Number 14, what are the x-intercepts? Well, that is the same answer as number 4. It is the value of x when y is 0. So we have 1, 2, 3, 4, 5. So those occur at x equals -2, x equals -1, 0, +1, and +2. Now you can write these as order pairs if you like, or you can write it like this. And the last question, what is or are the x-intercepts? Again, we can only have one y-intercept for this to be a function. If we had more than that, it would fail the vertical line test. There is one here, and that's at 0. So we could say when y is 0, or f of x equals 0, or if we wrote it order pair, it'd be 0, 0, the origin. Thanks for watching.